Hey, this is Brock Lemire's. We're continuing our study of embedded systems design. We are looking at the UART standard as part of the serial peripheral on the MSP430. In this video, we are going to send an ASCII character to the terminal of CCS. And this is a few new words for us to think about. And this is going to be a cool video because now we're going to start moving up a notch in terms of abstraction. So to start off with, a terminal is also called a console, is a way that you can communicate between a computer application and a device. And this uses the UART standard. And basically what it does is it sends characters back and forth. So this is how you can use you can use a terminal window, and you could print a message that is generated by the MSP430. And when I say message, it's English. So you can send your name or you can send a letter. And what's cool about it is all computers have a terminal, and you can set up their communication link, as a UART and tell it, number of bits and parity and no parity in the baud rate. But CCS actually has a built-in terminal, which is really cool, that we can use directly to interface with the MSP430. And it turns out that the MSP430 actually has a serial converter chip on it that allows the UART that comes out of the MCU to be converted into USB, and it comes up into a COM port on the computer. And this is pretty awesome because it kind of handles everything for us. So the key to this is that there's this thing called the application UART1, and that's the connection for the UART link to the MCU. And so when you look at your Launchpad board, remember that there's two UART peripherals. Okay, there's A1 and A0. A0 comes out on these pins. A1 is special. Okay, A1 is unique because it comes over and it goes through these header pins. And now what we've been doing is we've been looking at the header pins right here with an oscilloscope. But if we put that jumper back on, there's actually a chip in here that takes that UART and it makes the Launchpad board look like a COM port to your computer. And so when just like anything else, when you plug in a USB device, it comes up. Well, no, not every USB device, but a USB device can come up as a COM port, communication port. And so what happens is that there's actually two COM ports that are visible by your computer when you plug in the MSP430. One of them is going to be for the debug interface. So if you look at this, like for example, if you plug this in and bring up your device manager. And so on Windows, I just type device manager. And this is my computer, and I come down here and I start seeing these ports. And if you look at these ports, they come up as one of them is MSP application UART1, and one of them is MSP debug interface, COM port. And these COM numbers are assigned kind of every time you plug it in, you might get another one. But this UART interface gives us the ability to, if we write characters to COM5 from a terminal window, it will send it down to the MSP430 and it will arrive on UART A1 receive. And the same thing where if we send characters out to UART A1, it will come up and arrive on this COM port. And so what we can do is use a terminal window and we can send and receive characters. And the characters, I'm talking like typing from a keyboard. And so that's what we're going to look at today. This other one's really important too because it uses a COM interface to do the debugging. So like when we're stepping the program, it's actually sending commands down the USB cable into that chip that I just showed you right here. That is actually, then the chip turns around and it talks over this bus right here to the MCU, and that's how it steps it and reads out the information that are in the registers and everything. But today what we're focused on is let's send a character up the cable and let's see it on the computer. All right, now we're talking characters. So now we have to move up, and we're not sending ones and zeros. Well, we are sending ones and zeros, but we need to think about what a character is. There's a standard called the American Standard Coding for Information Interchange, which is called ASCII. And this coding says that every single character in the American language, okay, A, B, C, not just A, B, C, but capital A, lowercase a, capital B, lowercase b, is assigned a unique 8-bit code. And when they came up with this standard, that was the way that computers were able to send back and forth English messages. And so here's an example. So if I look at the hex code for capital A, it's 41. Well, you know what? Capital code, or the code for capital B, is 42. Even all the punctuation have codes. Okay, so like the at symbol is 40. If you look into this huge table, the comma has a code, it's 2C. The plus has a code, it's 2B. You know, colon has a code. So every character that we know of in our American language, English language, is assigned a unique 8-bit code. And as long as the sender and the receivers agree upon the code, or agree that they're using this ASCII coding technique, you can send binary information back and forth, and it's interpreted as characters. And now here's what's really cool. When you've programmed in C, you've probably used the data type car. Well, it turns out that car, when you do that, if I define something that was like car var1 equals A, what it's doing there is it's grabbing the ASCII code for capital A and it's putting it into var. And so that's what car means. Car means it's a character that is assigned a binary code from the ASCII table. And so when you go into memory, if you looked at what var1 was in ones and zeros, you'd see the ASCII code for capital A. So that's pretty cool. All right, so life is good. Let's do this. So here's what I want to do. Let's set up the A1 UART to talk to the computer, and let's set it up like this. Let's do a 115/200 baud rate. And from prior examples, we know that we need to use the SM clock, 1 megahertz, and then we need to set the prescaler to 8, and we need to set the second stage modulation to D6. And when we do a divider by 8, a prescaler by 8, then the OS 16 bit is 0 for low frequency. We don't use the first stage modulation, so we can just drop in hex D600 into the modulation setting. And then what we'll do is let's just get in a loop like we have in the past, and we'll send the character A up the cable. And we'll first look at it. We'll actually use A. We'll assign the character A into the transmit buffer. And then what we'll do is we'll take a look at it with an oscilloscope first, then we'll put the jumper on and let it rip, or actually use the console. Okay, so let's begin our project. So file, new CCS project. And we'll go ahead and call this C_UART_TX3. And then we'll go sending car. Alrighty. Main. All right, off we go. And here we are. We got our blank skeleton there. We're going to delete the little comment header and let's begin. So first and foremost, let's set up the UART. And UART A1 is what we're after. And so we got to put it in software reset like always. So we're going to go into the UC A1 control word 0 register, and we're going to go ahead and write a 1 to the UC software reset bit. So put into software reset, and this is going to allow us to do configurations without having to worry about something accidentally getting shifted out. And then let's set up our baud rate. So we're going to select SM clock. So that's in the UC A1 CTLW0 register again. And I'm going to do a bitwise OR and set the UC SSEL __ SM clock. So SM clock. And that gets me SM clock for my BR clock. All right, and then we're going to go ahead and set the prescaler. So that's in the UC A1 baud rate register. And I'm just going to drop an 8 into there. So then we do prescaler equals 8. And now we do the modulation setting. So I'm going to go into the UC A1 modulation control word register. And I got to remember that I'm doing 0xD600. And what that does is it says OS 16 equals low freak and set modulation. Second stage only. Okay, so now that's going to give me my 115/200 baud rate. Okay, and now we're ready to let's convert our port on port 4 over to port 4 bit 3. I want to switch its function to be the transmit of A1. So I go into the port 4 select 1 register and I clear the bit associated with bit 3, and then I go to the port 4 select 0, and I set the bit associated with bit 3. And what that does is changes port 4-bit 3 function to A1 UART TX. Okay, that is now good. So now what I need to do is turn on the digital I/O if I'm going to be driving the outside world. So I go to the power module 5, CTL 0 control register, and I need to clear the lock LPM 5-bit. So this is going to turn on GPIO or IO. And this is important. You can't, it actually doesn't work if you don't do that. I just realized that after screwing up. so I got lock LPM, but you got to spell it right. So lock LPM. It's still in it, is it? No, I'll get it. All right, now let's take it out of reset. And we're taking the, remember, this is the UART system, not the MCU. So now we're going to clear a bit. So I got to remember my tildes. And what this does is it takes UART A1 out of software reset. Okay, so now let's review this. Put it in software reset. Select my clock source, divide it by 8, apply modulation settings and low frequency mode. Turn port 4-bit 3 into the UART A1 TX function. Turn on the I/O and then take it out of the software reset. Okay, we're ready to roll. And what we're going to do is I'm going to have a delay loop. So let's go ahead and just get my loop variable declared. And then I'm just going to do a while 1. And here's what we're going to do. Okay, so I am going to drop a value, a character, into the UC A1 TX buffer. Okay, but I'm going to display it, or I'm going to define it, provide it as a character. So, oh geez. So I put the ticks, single ticks around it, and I put capital A. And now that's pretty awesome because that I've always done that when I program in C. Right? And what this does is it transmits ASCII code for A over UART A1. Now I've done this before. I've held characters in here, but I've never really seen a character get shifted out in binary. So that's what we get to look at first. It'll be kind of cool. So let's do 4 I is equal to 0, and then we'll do our standard. Let's just count up to 10,000, and then sit forever. And this is delay. All right, so we got it. All right, now I'm sitting here, and we are ready to roll. So let's go ahead and compile this buddy. Then we'll go fix our errors if we have any. Oh, doesn't have any errors. Okay. Okay. All right, life is good. Life is good. All right, so let's take a look at the board right now. So here's the board. I have popped off the header or the jumper from J101 so I can put my oscilloscope probe on TXD, and I'm using the analog discovery channel 1 to look at that. I go ahead and put ground and channel 1 negative to 2 ground pins right here, and I'm going to observe this with an oscilloscope first. I want to see the thing coming out. So what I want to do is I want to get my oscilloscope, I'm going to run it. So it's sitting there waiting, and I have my trigger set up to be falling edge, and let's go ahead and run this and see if anything comes out. Okay, here we go. Holy moly. Look at this. This is nice. So let me zoom a little bit. Not too much. Not too much. So then I come over here. Here it is. So here's our transmit. It start bit, and then it goes 1, 0, 0, 0, 0, 1, 0, stop bit. Now you look at that, and you're like, well, how big is this thing? So what I want to do is I want to let's measure this. So 8.55. Remember that 115200 has a bit period of like 8.6-ish microseconds. And so this is close. I mean, here's a 7.6. The modulation is doing the best it can, but it looks about like a 115-200 baud rate. And now if I go, let me switch back over to my little picture that I draw. And here's what I get out of this. When that oscilloscope shot, if I map the bit periods of what they are, whether they're a 1 or a 0, I get this. I get 1, 0, 0, 0, 0, 0, 1, 0. And what that means is that that's a binary code. But remember that LSB comes first. So I have to take these and I have to swap them around. And when I write it out the way that you would create the actual value, it's 0, 1, 0, 0, 0, 0, 1. Well, lo and behold, that is hex 41. And you're like, wow, that is crazy, because this hex 41 was provided to the computer program using a character in my code. So I use the data type character to send that in there. And you're like, where did it get the code for that? Well, it turns out it absolutely got it from the character or the ASCII code for capital A. And so when you do car as a data type in C, that's what it's doing. It converts that letter into an 8-bit ASCII code, and that's what's stored in memory, and that's what's moved around. Okay, so now that's cool. But now let's do this. Let us go ahead and let's go back to the board. And at this moment in time, what I want to do, actually, let's pause it. So I'm going to go ahead and pause this. And so that'll stop the transmission. And so now what I'm going to do is I go back to the board and I'm going to unplug my oscilloscope and I'm going to put the jumper back on. And so now what's happening is the jumper takes that A1TX and it runs it over to here, and it actually goes into this chip right here, which is the debugger chip and the USB interface chip. And it actually will send that UART up the application UART up the USB cable. So the question then becomes, well, who is receiving it at the other end of the cable? Well, the way that it works is that a computer has all these ports that come in, and we already saw that this comes in on COM5, I believe it was. And so you can have applications on the computer that will open up that COM port and send UART information back and forth. Well, what's good for us is that we can actually use a terminal application on the computer and receive the ASCII characters, and it will display it as a letter, or you'll see capital A. So here's what I'm going to do. I'm going to use the built-in terminal in CCS. So I'm going to come over here and I'm going to go up to View, and I'm going to say Terminal. And here's our terminal window right here. And what I'm going to do is I'm going to hit this blue button that says Open a New Terminal, and it asks me what kind of terminal I want. Well, I want a serial terminal. Okay, it'll probably come up as local, SSH. These are different types of terminals. We're going serial. That means just raw UART. COM5, it defaulted to that. That happens to be the application UART. And look at what are the other settings. Baud rate 115/200. I recognize that. That's what I set this up to be. That's the default value for this. Must be a good one. Data size 8, parity none, stop bit. Notice that we didn't even have to say LSB first, because that's the most standard. They don't even, I don't know who ever sends MSB first, but like this one is like, it won't even let you receive MSB first. So this is awesome. So our default framing settings out of reset are actually what a normal UART looks like by default. But you can come in here and change these. So you can see all these different baud rates that you can have, the data size. It'll let you do some wackies, 5, 6, 7, 8. MSP430 can only do 7 and 8. Parity, check it out, even or odd. We weren't lying. And then stop bit, how many can you have? 1 or 2. All right, decoding, leave it at that. Don't worry about what that is until later on. And so I'm going to go ahead and say, okay. Now, here's what it's doing. See this little flashing thing? Whenever it receives a UART frame or a packet, it's going to display what it thinks the ASCII character is. So now if I go back here and I hit run, so I'm going to sit here, and all of a sudden I'm looking down here, and lo and behold, a big string of A's comes out. And you're like, wow, that was cool. Oh, here comes some more A's. So this is sweet. It is actually receiving the character A over and over and over, and it's displaying it. So it's like, oh my God, this is awesome. Now, you should notice that it's really jerky, right? It's kind of like, it's just like, and then all of a sudden it spits out a ton of A's. The reason that that is happening is because remember that you're sharing the USB cable with the debugger COM port. So that USB cable actually is one serial link, but it has 2 COM ports. So it's switching back and forth between the debugger and this, but it's not losing any characters. But what's really cool about this is that if I come up here and I hit stop on the MSP, it doesn't stop the program. What it does is it just stops the debugger. So now if I come in here, my program is still running. And if I open up my terminal again, now I get to see the A's come flowing in one after another. And this time there's no conflict within the USB cable because I've turned the debugger off. And now the only thing coming up the debugger, or excuse me, up the USB cable is the ASCII character for A. And so now you get to see this really smooth tick, 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 tick. And remember, our delay corresponds to like 60 or 70 milliseconds. So look at that. That is so awesome. We actually get to see how a character in C is translated into binary, sent over a COM port using UART, received by a terminal on the computer, and then displayed as the original character that I started with. Holy cow, this is awesome. Now the world is changing. Things are starting to open up. Okay, you did it. Fantastic. Nice work as always. Remember, support my channel by subscribing, and see ya.